Hey guys, hello everyone and welcome to the channel. So from here onwards, I'm going to start this series on inorganic spectroscopy and basically on inorganic NMR spectroscopy. I'll be taking at least 3 videos on this particular topic. I have already taught other topics from inorganic spectroscopy like ESR spectroscopy and Mossbauer spectroscopy. So I'll give you link of those in the I button so you can watch in the I button. I will also make a separate playlist for inorganic spectroscopy, right? So inorganic NMR is actually very important because in the previous few years, if you will see, there are very direct questions which have been asked from inorganic NMR spectroscopy, and it's not as difficult as it seems, and it's not as straightforward also as it looks like. So inorganic NMR spectroscopy is quite similar to what you have studied it in organic NMR spectroscopy, but here it becomes little challenging because here you have more number of atoms which you have to deal with. So in organic NMR spectroscopy you only have carbon and hydrogen, which are generally NMR active, and others are NMR inactive atoms, and nitrogen also, right? That is NMR active. Others are NMR inactive atoms. Whereas when you come in inorganic spectroscopy, there are more nuclei which are NMR active, and there the complexity comes in. So in today's video, this is going to be part 1 of this particular series. So in this video, in today's video, I am going to tell you that how to find out the number of signals, like how many signals you are going to get, and the second thing which I will talk about is multiplicity. Okay, so multiplicity, how multiplicity takes place when you have different species around it. Now these things are very preliminary. It seems like it is very easy things, but the questions are asked on a quite complex basis from them. So I will request you all to watch the video entirely, understand the concept, and at the end of this video I will give you 2 practice questions so that you guys can also practice about them, and I will try to make it sure that I will explain the topic in such a way that it will be easy for you to solve any question which comes in exam. Alright, now having said that, let's continue with our video. Alright, so let's talk about number of signals in NMR spectroscopy. Now this thing is directly proportional, or you can say this basically tells you that how many types of different or you can say types of different species which you have in that particular molecule. So basically the number of signals will tell you how many different types of species you have in that particular molecule. So let's take an example of very famous molecule which is PF2Cl3. Now for understanding the structure of this PF2Cl3 and the other species which I am going to talk about, you need to know the basics of VSEPR theory and Bent rule. These are 2 things which you have to study. I will again give you link of those in the I button so you can watch those videos. I have already made on Bent rule also, and also on VSEPR theory, so you can watch those videos. So the structure of this PF2Cl3 is going to be trigonal bipyramidal, in which fluorine is going to go on the axial places, right? So we will be having something like this. We will be having the molecule something like this. Okay, so this is the structure of the molecule. Now if someone asks you that in the fluorine NMR, if you am doing 19F NMR of the same molecule, then tell me that how many signals I am going to get in this particular molecule. So basically you have 2 fluorines in this, but both of them are equivalent. How they are equivalent? See, both of them are on the axial position, and there is a plane. That plane is that equatorial plane which is bisecting or which is reflecting both these fluorines, making both these fluorine equivalent to each other. That is one way to understand. The second way to understand is to look upon the chemical environment. So this fluorine is cis to 3 chlorides and trans to 1 fluorine, alright, and the other fluorine is again cis to 3 chlorides and it is trans to 1 of the fluoride. So both these fluorine have same chemical environment, and that's why you will just get 1 signal in this particular case. Okay, so you will just get 1 peak in the fluorine NMR spectrum of this particular molecule. But now if I change the molecule and if I make it PF3Cl2, the structure again is going to be trigonal bipyramidal, but now the position of these groups are going to be something like this. So you will have fluorides on the axial position and one more fluoride will be on this particular position, whereas these are going to be your chlorides. So this is your equatorial plane. All right. Now if someone asks you that how many signals you are going to get for this molecule in 19F NMR, so first thing is to understand that what NMR they are asking. Whatsoever NMR they are asking, that species you have to see that how many of them they have. So if they are asking about 19F NMR, so you will look for the fluorides. If they are asking for 31P NMR, that is phosphorus NMR, then you have to see for phosphorus. All right. So here again, this is the equatorial plane which is basically bisecting these two, so making these two fluorine equivalent to each other. So this is fluoride of type A, this is also fluoride of type A, whereas this is another type of fluoride which will be fluoride of type B. Why? Because you can see both these type A ones are like trans to a fluoride and cis to two chloride and one fluoride, right? They are on the axial positions. And this particular fluoride, which is fluoride of type B, which I have mentioned over here, is basically on the equatorial position, and that's why it is different than these two. So that's why how many signals in the 19F NMR of this molecule you are going to get? You are going to get 2 signals over here. All right. So in that way you can easily understand for any molecule, if it is given and if it is asked how many signals you are going to get or how many peaks you are going to get. Sometimes it is also asked that how many resonances. Okay, so that's also number of peaks, and if it is asked number of signals, then of course that is the same thing, and if it is asked number of peaks, then also it's the same thing. So if any of these things is asked, then that means that you have to just tell that how many equivalent species are there, and just depending upon that you have to tell how many signals you are going to get. Now quite similar thing you are going to see when you have facial and meridional isomers. So let me tell you that what is a facial and meridional isomer quickly. So if this is some metal complex, and if I quickly draw the octahedral environment around it, so if this is the octahedral species, so facial isomer will be when my ligands are on one of the face like this. That means if you join these ligands, it makes a triangle like this, equilateral triangle, right? So that is called facial isomer. All right, whereas if my ligand goes something like this, let's say my ligands are now here, here and here, again you can join them, it will make a triangle, but now the triangle is not equatorial one. Okay, so they are not on the same face. That's what you have to see. So if two groups are basically trans to each other, if two groups at least are trans to each other, they will be meridional, they cannot be facial. Okay, so in order to become facial, they all have to be mutually perpendicular to each other, or they have to stay on the same face. If you are not able to imagine the molecule in facial form, you just have to understand that all of them have to be cis to each other in order to become facial, and in order to become meridional, at least two of them have to be trans to each other. All right, so let's take one more very quick example. Here I am going to have a metal, and now I am going to have a species, let's say PR3 is what I am going to have. Okay, so PR3, PR3 and PR3, this is going to be a facial isomer, right? So yeah, all right, so this is my octahedral environment. This is facial isomer, okay, of some metal PR3 whole thrice Cl3. This is the facial isomer of that molecule. Now if you find out, you will see that first of all you can understand that they are mutually perpendicular to each other, so they are facial. And now if it is asked in 31P NMR, in 31P NMR of this molecule, how many signals you are going to see. So whenever you have facial isomer, you will have only one signal. Okay, why is it so? That's because all these phosphorus are actually in same environment. See, this is trans to chlorine, this is trans to chlorine, this is also trans to chlorine, and it has mutually perpendicular to, like, it is perpendicular to 2 phosphorus, sorry, it is cis to 2 phosphorus and 2 chlorine. This is also cis to 2 phosphorus and 2 chlorines here. These are the chlorines which we are going to look for. Now this phosphorus is again cis to 2 phosphorus, these 2 phosphorus and these 2 chlorine, and trans to 1 chlorine. So chemical environment is same, and that's how you are going to see. So basically number of signals which we have seen, that is type of different species, it is indirectly telling you about the chemical environment. Okay, so chemical environment. If I take the same molecule and draw the meridional isomer of it, so in that case I am going to have okay, so let me draw the meridional isomer. What I said, for meridional you have to put the ligands over here on the axial line. Okay, so let us put it like this. We have chlorine, chlorine and chlorine. Now if you find out, you will see that these two PR3 are actually equivalent, right? Why? Because these two phosphorus are equivalent. Why? Because this is the plane or this is the equatorial position which is bisecting them or which is reflecting them, making them equivalent in chemical environment. Second way to see the chemical environment is to see that this phosphorus is cis to 1, 2, 3 chlorine and 1 PR3. This is also cis to 1, 2, 3 chlorine and 1 PR3, trans to PR3, right? That's what we have already seen. But this phosphorus is different from them. How it is different? Because this phosphorus is cis, or it is at 90 degree to these two PR3, right? It is at 90 degree to this also, and it is at 90 degree to this also. So it is 90 degree at 90 degree to both these two phosphorus which are on the axial position. So that's why, how many types of phosphorus now we have? We have two types of phosphorus. So how many signals you are going to get in 31P NMR? So you are going to get two signals in this case. So by this means, by the help of like finding out the number of signals, you can find out that how many isomers are there. You can distinguish between them, and that's the best thing about inorganic NMR spectroscopy. Now let's quickly take a question from previous year and let's see how it will be done. Right, so let's quickly look upon this question. It says in the 31P NMR, okay, whenever something is written like this in a curly bracket, it means that this is going to be read as proton decoupled phosphorus NMR or 31P NMR spectrum. Okay, decoupled means this species, this proton, is not going to interact with the phosphorus. Okay, whenever something is written in curly bracket, that means that species is not going to interact with the other species. All right. Now the question is that in 31P proton decoupled NMR spectrum of diamagnetic complex of meridional MPR3 whole thrice Cl3, where M is some transition metal having I value 0, expected number of resonances. How many number of resonances you are going to get? Okay, how many number of resonances means number of signals, right? That's what they are asking. So we have just done this question, right? We have just did this question. Meridional isomer, I have just done it. So you all have understood that the answer will be 2, right? So it's pretty simple. So first step to do questions from inorganic NMR spectroscopy is to find out how many different type of species are there, and that will have different signals, and now that can be taken forward to understand that what is going to be like the multiplicity of the peaks and all. So let's try to understand multiplicity. Right, so the second thing which we are going to cover in this video is multiplicity. Multiplicity basically gives information about the surrounding environment, or you can say what is adjacent to the group. So it talks about adjacent species. Multiplicity means the splitting of the peak. A particular peak is going to split up into more numbers depending upon how many different types of species are there around it, and depending upon the nuclear magnetic resonance like quantum number of them. So basically it all depends upon the I value. Okay, so I value of the adjacent species is going to decide that how many in how many lines it is going to split. Basically the formula which is going to be followed for multiplicity is going to be 2ni plus 1. All right, where n is the number of equivalent species. Okay, adjacent species, whereas I is basically the nuclear magnetic quantum number of different nuclei, and the values of I will be given to you in the question for most of the species. For those which you have to memorize or which you have to know is that for proton, for 13C, for 15N, for 31P, for 19F, for all of these species your I value is 1 by 2, whereas for 14N, for deuterium, okay, 2H or deuterium, your I value is 1. Okay, so these things you have to memorize or remember. For boron, the I value is 3 by 2. Okay, 3 by 2. So you have to remember few of the I values. The other I values in the question will be given to you. Okay, what is basically the I value they will be giving you. So how to do question based upon multiplicity? Let's look upon this. So let's say that I have a molecule PF3. Okay, so I have a molecule PF3 and I have to tell that in how many lines the phosphorus peak is going to split. So basically phosphorus is attached to 3 fluorides. Structure of this is going to be pyramidal, right? This is going to be pyramidal kind of shape. So we have 3 fluorines attached to this like this with a lone pair. Now all these 3 fluorine are going to be equivalent to each other. Why? Because they are all in the same chemical environment, so they all are equivalent to each other. What we are looking upon is 31p NMR. Okay, so we are looking upon 31p NMR. So in 31p NMR what will happen? See, phosphorus itself is not going to split. Phosphorus itself is just going to give you a single peak like this, but when these 3 fluorines are going to come, they are going to cause splitting and they are going to cause multiplicity. How many peaks they are going to split it into? So the formula will be 2NIF plus 1. Alright, so how many fluorines are there? 3 fluorines of same type. So 2 into 3, I value of IF is half, I already told you. So basically it is going to give you 4 lines, or it is going to split into 4 lines. So this single peak which was coming because of phosphorus is now going to split up into 4 lines like this. Okay, and since I value is half, so the intensity ratio of these peaks will follow Pascal rule, 1:3:3:1, and the spectra will look like this. Okay, something like this. So that's what happens according to the what species we have around it. Now let's say in the same molecule we are now, instead of finding out 31p NMR, we are now going to find out fluorine NMR. Okay, that is 19f NMR. In the same molecule, if you are doing 19f NMR, in that case what will happen? So 2n, who is going to split now? See, fluorine is not going to split on its own. Okay, fluorine will give a single peak. Who will split and since all the fluorine are of same type, so they are same species are not going to split each other. Okay, just like in CH3 in the methyl group, they cannot split themselves. Okay, that in the same way all the 3 fluorines are same or they are equivalent. That's why they are not going to split themselves. So a single peak because of this fluorine, and who is going to split that? This phosphorus is now going to cause a splitting. And in how many lines it is going to split? So 2NIP plus 1. So just one phosphorus is there, I value is half and plus 1. So if you solve it, you will get 2 lines. So basically if you are measuring 31p NMR, you will get 4 lines because these fluorines are splitting the phosphorus line, whereas if you are measuring 19f NMR, that is fluorine NMR, you will only see 2 lines, and those are because of the phosphorus which is splitting the fluorine lines. So mutually whatever NMR you are looking upon, based upon that your number of lines will be decided. I have told you both of them in the question, any one of them they are going to ask. Alright, so let's quickly take one more example. Let's say I have the same molecule PF3Cl2. Alright, so let's take again the same molecule. So what you will find out, I already told you that there are 2 types of fluorine. Fluorine of type A, right, and fluorine of type B. And now let's say we are measuring 31p NMR. In that we have to find out that what is the splitting or what is the total number of lines which we are going to expect. So there is just one phosphorus, of course, but that phosphorus is going to split, and make sure to understand that chlorine are NMR inactive. Okay, they are not NMR active molecules. So who is going to split this phosphorus? Of course fluorine of type A and then fluorine of type B. So how the splitting is going to take place? So basically 2NIA plus 1, that is going to tell me the splitting because of fluorine of type A, multiplied by, we always multiply because that is happening in the same molecule. When it is happening in the same molecule, you have to multiply, multiplied by 2NIB plus 1. That means the number of fluorine of type B, right? So the answer will be, how many fluorine are there of type A? So there are 2 fluorines of type A. So 2 into 2 and plus half into half plus 1. And how many fluorine are of type B? So we have just one of them. So 2 into 1 into half and plus 1. So you will find out that you basically have 3 multiplied by 2. So you will have total of 6 lines in total. And what type of line you are going to see? So the type of line will depend upon the like who has split it first. So if A has split it first, it will give you a triplet and then doublet. So you will call it doublet of triplet. Okay, that's how we call it. Alright, so you got total of 6 lines in this particular case. Alright, in the next video, in the next class, I'll also tell you about the coupling, and there you will be able to decide that who will cause first, who will split first and who will split later. So that part we will do in the next video, but for now you just understand that how splitting is taking place when you have different species. Let's see some questions and let's look upon them, that how we have to do those questions. Alright. Okay, so this was a question which was asked in CSIR NET 2017 exam. It says that find out the number of lines in the 31p NMR spectrum or signal for the diagram. This is the diagram which is given to you. Now you will find out that here so many different species are there which are NMR active. First of all, you have to look upon that whose NMR you are looking upon. So you are looking upon phosphorus NMR. Then that phosphorus, now phosphorus is going to split. Why? Because of the other adjacent species. So that is what you have to take care of. Okay. So how many types of phosphorus you have? Just one type of phosphorus. But since there are so many species surrounding it, they are going to cause the splitting. So let's look upon that how many splitting or how many total number of lines we are going to expect here. So see, this phosphorus is attached to 2 fluorines. It is attached to 2 nitrogens also. It is attached to 1, 2, 3, 4 hydrogen of type A. Let's call them hydrogen of type A because there are 2 hydrogens, and this is hydrogen of type B. Alright. So these many species are surrounding this phosphorus. How you are going to find out the splitting? So it will be 2NIF plus 1. That means the splitting caused by fluorine. Then 2NIN plus 1. Splitting caused because of the nitrogens. 2NIHA plus 1 means because of hydrogen of type A, and then 2NIHB plus 1. Alright. So this is going to be the total number of signals or total number of splitting for the molecule. Now everything is in multiplication with each other because all these species are in the same molecule. So how many fluorines are there? So there are 2 fluorines. So 2 I value of fluorine is half, we already know. Okay, I'm just writing here I value of fluorine is half, I value of 15N I already told you is half. So all the species here have I value half. Okay, plus 1. Talking about nitrogen, which is 15N, as mentioned in the question, it is mentioned that the 15N isotope is being taken. So 2 into how many of them are there? So 2, half and plus 1. Then 2 into how many hydrogen of type A are there? So basically 1, 2, 3, 4. So 4 into half and plus 1. And how many type of hydrogen, like how many hydrogen of type B? So there is just 1. So 2 into 1 into half and plus 1. Solve this out and you are going to get how much? You will get 3 into 3 into 5 into 2. So this will give you 90. Alright. So yeah. So this is going to give you 90. So 90 signals you are going to get for this particular molecule. This is how we do, and this is basically in the combined way. First thing is to find out how many different species are there, and second thing is to see the splitting caused by them, and in combined they will be asked for 2 marks or sometimes for 4 marks in CSIR NET exam. Let's do quickly one more question to understand. Okay, so over here it says that for the complex shown below in non-fluxional state. Now fluxionality, you don't worry about that. It's a non-fluxional state, means the molecule is just like the way it is shown. The expected 31p NMR resonance R. Okay, so here the I value is given to you as half. Okay, so phosphorus has a I value of half. Okay, so how many phosphorus we have? See, there are 2 phosphorus over here. One is phosphorus. This molecule is trigonal bipyramidal, by the way. Okay, so one is phosphorus which is basically equatorial, so I'm just calling it as E, and one is phosphorus which is on the axial plane, so I'm calling it as A. Now since we have 2 types of phosphorus, so that's why if let's say we start from equatorial phosphorus, okay, so let's do for equatorial phosphorus, what will happen? Who will split that equatorial phosphorus? All the other things are NMR inactive, anything is not active over here, only the other phosphorus is active. Okay, and this is not adjacent to it, but it is 1 and 2 bonds away. If something is at least 2 or 3 bonds away, it can cause a splitting in inorganic spectroscopy. That thing I will discuss in the upcoming video. That is called coupling and 2J coupling, 3J coupling. Those things we will discuss in the upcoming videos. But here for now, you just have to understand that it is 2 bonds away, so it can cause splitting. So who will cause a splitting? Who is causing a splitting? Who is causing splitting? So that is going to be phosphorus of type A, or you can say axial phosphorus, right? Now if axial phosphorus is causing splitting, in how many lines it will cause a splitting? So 2 and how many axial phosphorus are there? Just one. I value is half and plus 1. So you are going to get a doublet, right? 2 you will get, so it is called as doublet here. Okay, so you are going to get a doublet. Now since here we have done for equatorial phosphorus, in the same way we can do for axial phosphorus also. Who will cause splitting? Who is causing splitting? Who is causing splitting? So basically equatorial, right? Equatorial phosphorus. Now equatorial phosphorus is causing splitting. So again 2Ni plus 1 and 2 into half, sorry, 2 into, because you just have one equatorial phosphorus, half plus 1, again you will get 2, that is a doublet. So why we have done for both of them separately? See, in the all previous examples, we were, the species which was being asked, that was just singly present. So we were just having one species which was being asked. But here in this question, the species which is being asked is 2 times present, or it is present at 2 different places or 2 different environments. So that's why for both of them you have to do. So what you are getting how many doublets? You are getting 2 doublets. So the answer will be option number D, that is 2 doublets for this. Alright, so it is very simple, right? You just have to see the molecule, you have to understand it, and you have to write the answer for them. Okay, so let's look upon this molecule. It says number of lines shown by BH3 part of the molecule of PH3P 11BH3 in the proton and boron NMR. So how to do this question? This one also I'll explain you. First of all, you have to draw the molecule. So BH3, you know BH3 is trigonal planar, so I'm just going to draw it in a planar manner. Okay, so that's how my BH3 will be. Since it's a Lewis acid, so the other group, which is PPH3, which is going to be pyramidal in shape, right, which is going to be pyramidal in shape, is going to have a single bond with it. All right, because it's a Lewis base, so Lewis acid, so it will accept electrons from the phosphorus, right? So that's what we are going to see. Right. Now you have to tell that, okay, first of all these 3 hydrogen are of same type, right? So let's call them as hydrogen of type A, type A and type A. Alright, so since all these hydrogens are of type A, now what we have to look, let's look upon proton NMR. Let's look upon proton NMR. Who is going to split these hydrogens? Of course, boron is going to split it first, right? So in how many lines? 2Nib plus 1. Then is there any other species which can cause splitting? So phosphorus can also cause splitting. And since it is 1 and 2 bond away, see, from every hydrogen it is 2 bond away. So that can also cause splitting, and that's what we can write down like this. So how many lines we will get? 2 into, how many borons we have? 1 boron. I value of boron is given to you is 3/2 in the question. Alright. Whereas let's talk about phosphorus. So we have 1 phosphorus. I value is 1/2 plus 1. Let's solve this up, and in that case we will get 4 into 2, that is 8 lines. Simple, 8 lines we are going to get. Now if I do 11 boron NMR, 11B NMR if I do for the same molecule, so who will split this boron? See, this boron will be splitted because of phosphorus and also because of these hydrogens which are surrounding it, right? So first of all, we will write down 2NiP plus 1, that means splitting because of phosphorus, and then 2NiH plus 1, that is splitting because of hydrogen. So you guys have to write down, or you guys have to solve this and tell me that how many lines you are going to get. How many lines you are going to get. Okay, you guys have to tell me, and also you have to tell me which will be the correct answer in this question. Alright, so this I am leaving for you. I'll also give you some more questions so that you can practice it out. Alright, so for this class, I'll give you some very basic homework so that you guys can practice. So this basically is a question. It says how many signals will be observed in a 19F NMR of SF6, CLF5, XZOF4, SF4, CLF3 and IF7. So these are the molecules and you have to look for 19F NMR, means you have to only look for different types of fluorine here, right? So try to answer these things in the comment sections below. Again, there is 31P NMR. So for 31P NMR means you have to look for the different types of phosphorus over here. So P4 and P4S3, these are two molecules where you have to look for the different types of phosphorus. So that's it for this particular video. In the upcoming video, I am going to teach you the splitting in the presence of metal complexes, like if the metal is also present in the complex, how you are going to decide the number of splitting lines. The basics will be same, just a new type of questions will be included over there, and I'll be explaining about role of coupling constant and how the coupling constant changes the pattern of splitting. All right, so these things we are going to discuss in the upcoming class, so stay tuned for the next video. Also, if you are watching this video after so many days of uploading it, in that case I will make the next part in the recommendation section or at the end of this video. Okay, so you can click over there and watch the next part of it. So that's it from my side for this video. Thank you so much for watching, and I will see you guys in the next one. Till then, have a great day. Bye bye, take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.